Today we're talking about equations with variables on both sides. If we have 6x plus 3 equals 8x minus 21, notice that we have a variable on both sides of the equal sign. So the first thing we have to do is have the variable on one side. So what should we do? Okay, which one do you want to take to the other side? 8x. Okay. To move 8x to the left, we have to subtract 8x, because it's the inverse operation, minus 8x. 6x minus 8x is negative 2x. Bring down our plus 3, our equal sign, and we're left with minus 21 and negative 21 on this side. Now, does this equation look more like what we had worked with before? Yes. So now that we have the variable on one side of the equal sign only, we can start solving by subtracting 3. So minus 3 is the inverse operation. What you do to one side, you do to the other. Negative 21 minus 3 is negative 24. That would be equal to negative 2x. Have we finished solving? No. So to have x by itself, what is the inverse operation? So we divide by negative 2. What you do to one side, to the other. X is equal to 12. Can we check this equation? Yes, if we're checking and we have 6x minus 3 equals 8x minus 21, and we substitute for our variable, we would say 6 times 12 minus 3 should be equal to 8 times 12 minus 3. So 6 times 12 is 72 minus 3 should be equal to 8 times 12, 96. This is not minus 96 minus 21. What's 72 minus 3? No. What's 96 minus 21? So what happened? Is this correct? No. That means we did something wrong. What did we do wrong? Oh, I see. The mistake is right here. This should be a plus 3. This should be a plus 3, so I copied down the problem wrong. 72 plus 3 is, and 75 equal to 75. So now is our problem correct? Yes. If we have to solve negative 60 equals d plus 4, we have to begin by taking our variable to one side. So minus d minus d. Negative 6d minus d is negative 7d, and that's equal to 4. To have the d by itself, we have to use the inverse operation, divide by negative 7, divide by negative 7. So d is equal to negative 4 over 7, or the decimal version, which would be negative 0.571. We have to solve 2 times c minus 6 equals 9c plus 12. First thing we have to do, I'm sorry, not plus 12, plus 2. The first thing we have to do is distribute the 2. 2 times c is 2c, minus 2 times 6, 12, is equal to 9c plus 2. Once we've used the distributive property, now we have to get the variable to one side. So let's move the variable to the right. Minus 2c minus 2c, negative 12 equals 7c plus 2. Got our variable here, so now we have to start solving for the variable. Subtract 2 from both sides. Negative 14 equals 7c. We have to divide by 7. Negative 2 is equal to c. Any questions? We have 10 minus 8a equals 2 times 5 minus 4a. We have to begin by using the distributive property. So 10 minus 8a is equal to 10 minus 8a. Does anything catch your eye? Yes, sir. Okay, they are both exactly the same. This means this equation is an identity. This equation is an identity. It means it is always true. It means that any number is a solution. If I continue solving this, if I add 8a to this side, and I add 8a to this side, this equals 0, right? And this equals 0. So in other words, we're left with 10 is equal to 10. If we substitute any number, in this equation, it will make it true. So let's choose a number. What would you like to substitute for a? I'm sorry? 4. Okay. If a equals 4, we could say 10 minus 8 times 4 should be equal to 2. 5 minus 4 times 4. And let's check this. 10 minus 32 should be equal to 2 times 5 minus 16. 10 minus 32 is what? Negative 22 should be equal to 2 times 5 minus 16. Is this true? This is a negative 11. This is true. So this type of equation is called an identity because any number is a solution. 6m minus 5 equals 7m plus 7 minus m. We have to start by combining the like terms on the same side of the equal sign. So we have 7m minus m, 6m plus 7 is equal to 6m minus 5. If we subtract m from both sides, so it's minus 6m minus 6m, we have 0. Minus 5 equal to 7. In other words, negative 5 equal to 7. Can that be true? No, this cannot be true. Therefore, there is no solution.